Ever wondered how scientists separate and analyze mixtures of chemicals? Well, they have a secret weapon called chromatography. This fascinating technique is a bit like a race, where different components of a mixture travel at different speeds through a stationary phase when carried by a mobile phase. Imagine a group of runners. They're all starting at the same line, but some are faster than others. The faster runners represent the components with less affinity for the stationary phase, meaning they'll move through it more quickly. The slower runners, on the other hand, are more attracted to the stationary phase and thus move more slowly. This difference in speed allows the components to separate, making it easier to identify and quantify each one. There are several types of chromatography techniques, each with its unique stationary and mobile phases. Gas chromatography, for example, uses a gaseous mobile phase. In contrast, liquid chromatography uses a liquid mobile phase and can be further divided into subtypes like high-performance liquid chromatography, ion exchange chromatography, and more. Other types include thin-layer chromatography, which involves a thin layer of adsorbent on a solid support, and paper chromatography, which uses paper as the stationary phase. But the uses of chromatography aren't limited to the lab. It's a vital tool in a variety of fields, from drug testing and environmental analysis to food and beverage quality control and forensic science. It's even used in the purification of chemicals and biomolecules in research and industry. After separation, the different components can be detected and quantified using various methods, depending on the specific chromatography technique used. Some of these methods include UV, visible, spectroscopy, mass spectrometry, fluorescence, or conductivity. Chromatography also shines when it comes to both qualitative and quantitative analysis. It not only helps separate mixtures, but also quantifies the amount of each component present. In column chromatography, the stationary phase is packed into a glass column, and the sample is introduced at the top. As the mobile phase passes through the column, the components separate based on their interactions with the stationary phase. One critical parameter in chromatography is the retention time, the time it takes for a component to travel through the system and reach the detector. This parameter is key for identifying and quantifying components. Over time, chromatography techniques have evolved, becoming more efficient and precise. High-performance liquid chromatography, HPLC, is one of the most advanced and widely used methods for separation and analysis. So remember, next time you see a group of runners, think of chromatography. It's a race where the finish line means separation, identification, and quantification of the components of a mixture. A race that is crucial to various scientific disciplines and industries, a race that quite literally helps make sense of the world around us.